Hello, welcome back to INFR 2670. This is lecture 5. It's going to be a short lecture because we will have a hands-on activity. Um, so I want to make sure we don't, have too much content. But this is very interesting, and it's networking with VMs. I also don't want to step over any other courses, maybe intro to SDNs you're gonna have, because this is a perfect topic for that course, right? So in that course, you'll go into details of vSwitch and all that, VXLAN and etc. So here, I'm just going to discuss the basics because we're dealing with virtualization, VMs, and how do VMs network, right? We have to understand, to have an idea of how they network. And also, because this week we will have a hands-on activity on LXD and LXC, I want to bring it back, give you more information about LXD, and then prepare you for the hands-on activity. All right, so here we go. So networking and VMs, how do they network, right? Um, well, you know, virtualization is really important to cloud computing and server consolidation and all that. Virtualization will pack many applications in a VM, right? And will run multiple applications or multiple VMs in a single server, correct? So how is networking handled in a scenario where there are multiple VMs in each server and also multiple servers? How the hypervisor, what is behind this kind of environment that will handle networking? Okay, and basically, obviously, right, a VM that cannot communicate with any other element is not very useful, right? If you have just a standalone with no network connection in a VM, it won't be very useful, right? And then we have some challenging questions. Which software or what entity should control the physical network interface? Another one, how should VMs communicate with external resources? And how should VMs on one host be isolated from each other? Let's take a look at this and see if we can find answers, right? So the first question, which software or entity should control the physical NIC? Well, standard VMs should not control the physical network, not only to avoid becoming a bottleneck for VM traffic, but also to prevent other VMs from accessing this resource, right? The hypervisor should be the one to control the physical, the NIC, sharing the resources with all the other hosted VMs. It makes much more sense, right? Well, now, how should VMs communicate with external resources? We can have different solutions. We can have layer 3, which is routing, right? Network layer. Or layer 2, MAC layer bridging. How can we do that? So layer 3 routing usually provides better isolation, but it requires deployment of routing tables and protocols and subnetting and etc., right? You will have subnet issues, for example. Layer 2 forwarding or bridging is much simpler and more common, all right? As you will see, we can also implement, with that, we can implement VLAN, virtual LAN solutions, okay? So, yeah, so I was talking about VLAN. What about VLANs? Virtual LANs, right? Let me get my pen here. So if you take a look at you have two hosts, host 1 and 2, and each one is running 2 VMs, right? You have your network down there, you have your interface, network interface 0. You have another layer here that will expose a virtual link, right, or interface, and the VMs are communicating with that exposed link through TAP, which is everything is software, right, or virtual or virtualized. Okay, let's see how we can do that. So before we go into vSwitch and other things, let's take a look at the VM networking options. When you are installing, running VMs, you have the option to select what kind of network adapter or the network, how can I say, scheme that your VMs will use to communicate with other VMs and externally. So we have basically not attached. It's a standalone VM with no network adapter, right? So no networking. We have NAT, bridged adapter, and host only. Okay, you can see here in the picture we also have internal, host only, and generic. Well, internal will create a network between the VMs, but they're not visible to, it's not visible to the applications on the host. All right, so internal can talk to the outside world, and host only can't. All right, and generic, it's rarely used, but it allows you to share a specific network driver. Honestly, I've never used generic driver. So VM NAT mode, one of the options that we select there, right? So typically the default configuration, no additional configuration required on the host machine or the network. So what happens here is, so the hypervisor is responsible for sharing the physical network interface, right? So it uses the physical network adapter as a NAT router. So it exposes that as a NAT router that the VMs will use to connect to that to outside world and anything. So the VMs, they connect to this NAT router using a TAP, a software-based data link, all virtualized, all software. All right. So it's important to note that we need port forwarding when you're running a virtual server in NAT mode. All right. So Here, so you have your, um, well, a switch giving us this address, and this is your physical server running multiple VMs, right? And this is the address given by that we use to connect through the NAT router, and that's how each VM will have a different network interface, and they can connect to the exterior, the external network. All right. So bridged mode is also very common when we're working with VMs. So in bridged mode, the VM is assigned an IP address on the physical NIC. It means you will get, so again, let's say we have this, right? And then you have a NAT. So this is the address given to the VM behind a NAT. All right. Now in bridged mode, as you can see there, it is assigned an IP address on the physical NIC. So that's your address. All right. And then the hypervisor will be able to use what we call a net filter to create a new software driver. Make sense? So in NAT, you will get, it's a NAT router on the physical server that will give you a NAT, a different address. It's not on the network, the external network, on the physical NIC. Now Bridget will give you an IP on that physical NIC. All right. So just to summarize NAT versus Bridget, I have this diagram here that shows let's call it a production network, and this firewall, let's say this is a firewall on a company, and this is the firewall's IP address, 192.168.1.1. You can also see that we have a physical machine connected to that, and it's a virtual host that holds 3 other VMs. All right. You can see the big red circle there. It represents the virtual adapter to which NAT-based virtual machines connect, which has the address 172.16.1.1. Right? Okay, so far. So, and you can see that the 2 virtual machines here they have IP addresses on the same network as the NAT IP address, right? So 172.16.1.2, this is 2, and then this is 3. All right. So when you configure a VM as using NAT, it doesn't see the external network or the production network directly, okay? In fact, all traffic coming from a virtual machine will share the VM's, the host's IP address, all right? Well, basically, traffic from VMs will be routed on the virtual host, and then from there sent out to the host physical adapter, and then eventually to the outside, to the internet. All right. Makes sense, right? So you also have a third VM there. Let me just, the third VM there which is 192.168.1.3, it is configured, as you can see, it is configured as bridged. All right, what does that mean? So that virtual machine operates as if it exists directly on the production network, on the external physical network. All right, so it gets that IP address, and then there is a virtual adapter with that IP address, and it looks like it is directly on the network, on the production network. All right, and in fact, if you look at this diagram, that machine, that VM with the bridged VM will not even be able to see the other two VMs. Well, basically because they are on different networks. All right? That's how you can work with provide isolation and all that. Okay. Now, VM host-only mode, the physical port need not be connected to the outside network. What does that mean? So the hypervisor will create a virtual loopback port on that host, and then the VMs can communicate between them, but the VMs that will reside on that physical server, of course. All right. So internal networking is similar to host only, the other option, internal, except no loopback is created, and therefore the traffic between the VMs cannot be intercepted on the host. All right. Obviously, you can implement a combination of options when you are creating your virtual network, right? So in a single host, you will have multiple VMs, and they can have any options, any networking options selected, right? So, for example, we have here a web server, right? A client that is behind a NAT, and we have a database server, correct? So the web server, as you can see, it uses bridged mode to provide public access, right? And it also uses a second host only right there. So this second network interface is host only, but to connect to the database server. All right, so here they connect internally. All right, and since this is a host, the server is host only, it's not visible from outside. So a client here, for example, behind a NAT, will be able to access or anything externally, right? Because it's bridged mode. Well, any other client will be able to connect to the web server, but not the database server, all right? But the web server can connect to the database. Okay, this is how we can provide the isolation and separation. Very, very cool, right? Now we come to another, well, continuing on networking, virtual networks. A virtual switch. What is a virtual switch? So the virtual switch is basically a virtualization aware software running on each server that uses the same networking protocols and the physical switch. All right. So it is a software abstraction of a layer 2 switch. All right. It emulates a switch. Okay, sends and receive frames, right? Ethernet frames. It was first created by VMware, and then later on the open source Open vSwitch took over, and it's the commonly used. Physical links are uplinks to vSwitch. So the virtual switch, or vSwitch, it forwards all the traffic to the physical interface on the server. Okay. Now, why a virtual switch then? You may ask, why do you need a virtual switch? Well, think about the how do you configure your network topology, and a real network topology, not a virtual one. How do you configure the topology and you place your switches and everything? Right. Now, think about VMs. A VM is something that can be spawned and deleted easily, right? And that will happen most of the time, meaning topology will change constantly. Now imagine having to manually place switches for VMs. That doesn't make sense, does it? So it's one problem. It's hard to reconfigure and provision physical switches for such dynamic environment, right? So, and also not only that, but limiting to a physical switch will limit the mobility and the scalability of your VLAN, your entire network, right? So that's why we need a virtual switch. And how does it work? So it's I just want to give you the concept here, because you will have you will look into deeper into vSwitch in the lab, in another course, not in this one, in Introduction to SDNs, and there are other courses that will touch more into this, so I don't want to step over them. But basically, just to give you an idea of how it works, right? So each VM emulates at least one network card or interface, right? The virtual interface it emulates a physical interface. So obviously it generates real Ethernet frames, all right? And it sends them to the vSwitch through a virtual link, a bridge. All right, there is no physical connection, it's just a bridge. Okay, vSwitch, after analyzing the destination, it'll check the destination's MAC address to determine if this should go to the outside or it's internal, or if it's coming from another VM. All right. So it analyzes the MAC address and decides if it should send the frame to the physical network interface or to a VM whose virtual network adapter is connected to the same VLAN. Meaning, if the MAC address is the same as the physical address at the host, it's coming from a VM, so it's a VM in the VLAN, right? So if a local VM is the destination, all right, the data doesn't even leave, it doesn't leave the physical server, right? It doesn't need to. So internally, it's just a memory-based operation. When one VM is sending a packet, a frame, to another VM in the same machine, right? It doesn't need to go outside to the network. It's just a memory-based operation, okay? So that optimizes and makes it much easier to deal with switches in virtual networks for VMs, okay? Now, another little topic within the same theme, which is virtual network services. What are those, right? So just some examples here. You can have, let me get my pen here. So you can have security, firewall, network services, right? Load balancers, packet inspectors, intrusion prevention systems. You can have intrusion detection systems. You can have proxies, gateways, traffic shapers, etc. These are network services. Why am I talking about them? Well, physical network service deployment. How does it work in a physical network? So network services, they have to be deployed either as standalone devices in the traffic path, of course, or as features integrated into the physical network devices, right? Again, this is not very flexible when we are dealing with dynamic topologies, when you're using VMs, right? So not very flexible, limited to physical network topology, requires additional cabling power, etc., etc. Right? So then we have what we call virtual network services. We have a virtual service data path, VPath, that can be established to steer traffic through various virtual network services. Basically, another encapsulation layer. It's not limited to physical topology. Right? It can be placed anywhere in the VPath with the help of VPath. And for example, you can have a load balancer moved anywhere in your network. Okay? And obviously, before you go into LXD, with VLANs and everything, that's what I want to say, the final words is you can have multiple of those network service as virtualized and spawn on demand according to user demand, CPU processing demand, and as your network topology changes, that is much easier to deal with instead of using physical network service devices, right? All right, so that's it for networking within VMs. So what is important there is that so VMs, they need to communicate somehow, right? And you will have VMs that will communicate with other VMs in the same host. So we saw with vSwitch we can do that. We saw all the options of networking options you can have when configuring a VM and how they differ, how they work. And you can also have a hybrid approach, different VMs within the same host with using different network options to provide that isolation. In the example of the web server that accesses a database server with a host-only connection, right? And then that web server has a bridge, it's bridged, so you provide access to external resources or to external machines, like clients can connect to the web server. All right, that's how you isolate. And since it's host only, the database server will not be accessible externally. All right, so this is what is important from this lecture. Now let's take a look at LXD and LXC. We saw briefly last class, but because we're gonna work on this, like I said, let's just have a little introduction to what LXD is, and then we'll move on and have the hands-on activity. All right. So what is LXD? Let's take a look at that again, just to make it clear. LXD is a container manager. It is a hypervisor, but instead of VMs, it's a hypervisor for containers, basically. Okay, it brings an experience similar to VMs, but using a Linux container instead. All right, an LXD container gives you a full machine, not just a process like Docker. Docker, remember, a Docker container is a process running. Here we have a full machine running on a hypervisor, which is LXD. And since Docker is a process, you can also run Docker on top of LXD. Okay. And LXD is built around a REST API. What is REST API? Well, it's a software architecture that it defines a set of constraints to be used for creating web services. And those web services that conform to REST, they are called RESTful web services. And they provide the interoperability between computers, systems on the internet. And basically, the requests made by, to a RESTful web service will be the response coming from those web services will be formatted, or the payload will be formatted in, you know, HTML, XML, JSON, or some other format that is easy and to read, and so it's compatible with anything on the web, basically. All right. LXD features now. So it's secure by design. You have unprivileged containers. You have resource restrictions and much more. All right. It's scalable from containers on your laptop, for example, to thousands of compute nodes in cloud. All right. It's very intuitive. It's simple. It's very simple. There is a clear API, and the command line experience is very simple, and at the same time it's robust, and you can do many things. It's image based, meaning there is a variety of, there are so many Linux distributions published daily, actually. Okay. What else? It's support for cross host container and image transfer, which also includes live migration with an external package, CRYU, which I've had some problems with, but I'll try to fix them. You have also advanced resource control. CPU memory, network I/O, block I/O, disk usage, and kernel resources. Device pass-through, you can pass through USB, GPU, Unix character and block devices and network interfaces, disks, paths, many things. All right. Network management. Network management provides bridge creation, for example, and configuration, cross-host tunnels, etc., etc. There is also then storage management. Storage management. So support for multiple storage backends, storage pools, and storage volumes. All right, those are the features of LXD. Now, LXC is what is the actual Linux container. Okay, it's a user space interface for the Linux kernel containment features. You can create and manage containers through an API and simple tools, as you will see. LXC can create an environment as close as possible to a standard Linux installation, but without the need for a separate kernel as we do in full VMs. All right, and LXC is free. Summarizing then, because now you know a little bit more of Docker. So, like I said before, many times, Docker runs simple single processes. LXD provides a whole guest OS. All right. LXD provides you with supportive services like logging, SSH, etc., whereas Docker only runs a single application. Docker supports DevOps and platform as a service deployments. LXD focuses on the IaaS, okay, on the infrastructure. You can run Docker on LXD. Docker is just an application wrapper service. This also has almost zero impact performance when running Docker on LXD. All right.